All right, you guys. Welcome to Equations of Circles. I really hope you all are watching this video before class, as we've been working on all year, because some of this is not too bad, but there is certainly a tricky side of this. I would really want you to see this before we got to class and try to apply it more. We're going to do a bunch of examples, and we're going to take a look at this. Equations of circles. So we're talking about basically an equation in the coordinate plane. All right. The question is, what is the standard form? What does an equation of a circle look like? Well, I'm going to write it down. Don't panic, because we're gonna take a look at this, and I'm going to show you that it's really not that bad. But the equation of a circle, the standard form would look like this: x minus h squared plus y minus k squared equals r squared. Do I understand that that looks a little scary? I get it. No panicking. Just understand the x and the y just represent all of the points on the circle. The rest of these letters have a lot of value. What we would need to know about a circle before we try and graph it, we better know where the center is. Well, if we have our circle in its standard form, the center is always going to be at h comma k. All right? So the x value of the center is here, but be careful. See, this says x minus h. So if this said x minus 1, if I want to know where the center is, I'm going to put 1. All right? The y value of the center is located right here. Again, only if we are in our standard form. And it's going to always equal r squared. The radius is whatever r is. So please understand, if I know where the center of a circle is, and I know the radius is 3, if I'm on the coordinate plane, I can go 3 units right, 3 units down, 3 units left, 3 units up, and I can probably draw a circle, even if it looks like some sort of beat up orange kicked down the street. We can get pretty close to a pretty good graph. Okay? So let's just look at some examples here. All right? If I gave you the center and the radius, which is a question on your quiz and your test, could you actually write the standard form of the circle? So just, I'm taking from straight right here. If I'm going to try and write the equation, I would write down parentheses x. That says minus, and then I'm going to plug in a 2. Please notice that if that's a positive 2, in the equation it's going to say negative 2. Now watch what happens when these numbers are actually negative. I would write down y minus, and then I would put in negative 3. We'll come back and clean that up in a second. Equals, and the formula, the standard form is r squared. Well, if the radius is 4, then I want to find out what 4 squared is. So just understand, there's some cleaning up to do here. There's nothing more to simplify. This is just x minus 2 squared plus, but whenever we have minus a negative, that's going to become a positive. And please understand, we're not going to be squaring anything. We don't change this because there's very valuable information there. The one thing we will square is this number over here, because that's pretty simple and we have the ability. Okay? This would be the correct answer to this problem if the instructions were write the equation of a circle, if you knew the center and the radius. So let's play again. All right? If I know the x and the y value, again, I'm plugging in, and watch this. Sometimes I'll x minus, and instead of putting a negative 1, I'll go negative 1, and I'll clean it up as I'm entering it into the equation. All right, and then I have y minus 0 squared equals the radius, which is 10 squared. Again, I want to clean a little bit of this up. I already cleaned this up, so there's nothing more to do there, but y minus 0 is just y squared. So if there's no number there, sometimes you won't see it written. And 10 squared is 100. This correct answer. So these two problems is taking the information and plugging it into the standard form. Well, we have to be able to do the reverse of that. If I give you the equation, I would want to know what is the center and what is the radius. So we got to be smart on how to pull things out. Now here I don't see any numbers. What we just learned, all that means is that my center is at 0, 0, otherwise known as the origin. Now the radius, be careful, is not 25. 25 is whatever r squared is. So if you want to find out what the radius is, you better square root that number. Square root of 25 is 5. This is the information I would have been looking for. I can go graph the center, I can count the radius in 4 directions, and I can graph my circle pretty easily. Okay? Now let's look at the next example. A little bit more complicated, but remember, we got to be careful. The center of this circle, it's not at -3 and 5. I know that because I can go back here and remember when I put this center in, when I put that 2 in, it changed sign. So if I tried to reverse this process, I better change the sign back. Same thing here. If that was a negative, here it becomes a positive. The reason they're opposite is because the standard form has that minus sign. Minus just means change. So when it got plugged in, the sign was changed. When I pull it out, I'm going to change it back. If this is a positive 5, that means before it was plugged into the standard form, it was negative. And try and remember, my radius is not 4. 4 is whatever r squared is, so I need to square root that, and my radius is 2. Again, if I wanted to graph, I plot the center, and then I count the radius in 4 different directions, and I can draw my circle. Okay? This is certainly the basic version of the standard form of a circle. If you need to, pause, rewind, look at this again, because here's where it gets a little bit more difficult. What if my equation did not look like the standard form? All right, it's just like if the equation of my line is not slope-intercept form, I can't just look at it and know the slope and the y-intercept. Here, I need to make this, I need it to look like this. All right, the way we do this is a process called completing the square. Now, in the past, I've tried to come up, because this is not an easy task, I try and come up with a procedure. Here I have a 5-step procedure that we're going to walk through and do together on trying to change. Again, we can't change the equation. We can try and change the way it looks. We want it to look like the standard form. So let's go step by step. If I want to do step 1, I want to do what's called isolate the variables, and I'm going to leave a blank for C. When I say C, please understand that these are the way the squared situations look, we referred to as the number in front of x squared being A, the number in front of the x being B, and if we have no variable, then we call that C. So the number in front of the squared would be A, this would be B, and we're going to get to a new version of C using a process called completing the square. So watch this process first, and we will practice several times in class. When I say isolate the variables, I want to put the x's together inside of a set of parentheses, and I'm going to leave a blank for a new, so remember the number in front of here is A, B, and I'm going to leave a blank for this new value of C that I'm going to find out. So there's the x's. Let's put the y's together the same kind of way. Y squared minus 6y, and leave a blank for a new version of C. And I take that, this is what's called a constant value. There's no variable next to it, so this number is not going to change. The rest of these can all change based on what x and y are. I need to move that constant value to the other side because, again, I want to isolate the variables. I want to get them all alone. So the only way to move that to the other side is to add 3 to both sides, which means on the other side I have a positive 3 now. Isolate the variables and leave a blank for C. Isolate the variables and leave a blank for C. That's step number 1. So maybe I'll even make a little note. That's how you do, can't see that, can you? That's how you do step 1. Okay, but let's come back over here so we can see our procedure. Now the next instruction is I want to find out what half of B is. Remember, B is the number in front of the single powered variable. So here, half of B, half of 4 is 2. Here, half of B was negative 3. But I also want to square that. If I square this value, I get 4. If I square negative 3 times negative 3 is a positive 9. That's how we do this next step. Notice I wrote down what half of B was, and I squared it. I wrote down half of B and I squared it. Step 3 says we want to plug that in. That's going to be our new value of C, but also says, and you better compensate, because here's the big deal. If I take and I put that new value of C, this 4, I'm dropping into that blank. Taking that 9 and putting it into that blank. We've actually broken a mathematical law. We just changed the left side of this equation. You're actually not allowed to do that unless we do the same thing on the other side. So if I added 4 and I added 9 to the left side, let's come over here and add 4 and add 9. That's what it means to compensate. So we remember, we want to make the equation look different, but we don't want to exactly change the equation. We just want to make it look different. Okay? Now, step 4 says we're going to factor. The good news is the reason that we did this here, this is going to factor into x plus whatever half of b was squared. So it's always going to factor into something very pretty like this, and that's always going to be whatever half of b was. Same thing here. That's why we want to write down whatever half of b was. So this factors into actually x plus, and I want to bring that half of b and drop it in there. You did some factoring in Algebra 1 whenever you were there. I'm just trying to help you out a little bit and tell you that this is going to factor the same way every time. Again, whatever half of b was, that was a minus 3. And on the other side, I had 3 plus 4 plus 9, which actually adds up to 16. Now, if you look, holy smokes, we are in standard form. If we're in standard form, that means the center of our circle is now staring us straight in the face. The x value's got to be right here. But remember, when I pull that out, I'm not going to write a 2 because I need to write down the opposite of 2. I'm not going to write down negative 3. I'm going to write the opposite down. And my radius, it's not 16. It's whatever the square root of 16 was, which was 4. This, what we did is we took an equation of a circle and we manipulated it until we got into, remember, this is called standard form. If we can get it into its standard form, the center and radius are staring us straight in the face. We just need to know enough to grab them out of there. I understand this is not easy, but this idea of completing the square is certainly something you will use in Algebra 2, which means now in the end of geometry is a great time to be exposed to this idea. This procedure, in my opinion, will work every time. We'll practice it in class. I really hope you watch this video before you come to class, otherwise you'll be pretty lost. Good luck, see you in class.